Android do have a pretty good YouTube channel. So I watch that pretty frequently. They have pretty good things. And then there's other people who put out tutorials and information on Android Studio. So if you have time and you watch YouTube, there's a lot of information out there. People who says, this is how you do it, this is how you don't do it, this is how you do sidebar, this is how you do that. It's fairly interesting. I do pace around, I do move around a lot. I'm not hyper, you know, but it's just the way I think. It drives my wife crazy, but I don't stand in one spot, so don't think that I will. Don't look at me funny. I just do. Okay? So, is there any other questions or setup issues or anything else? Okay, well, why don't we just kind of begin just a little bit. I go a little bit slow. Again, the purpose is I'm going to give an overview of a lot of things, and then we're going to dive deep and do some coding, examples, and all of that. Android, as many of you may know, is built upon a Linux kernel. It's kind of hard to tell that because as you're programming, you're really not into it because you're into the IDE. You really don't get a feel for it, but it is based on a Linux kernel. To do an Android application, there's a couple of ways that you do. One is with Java. Java is by far the cheapest and easiest way to get into Android programming, but it's not the only way. You can use Xamarin, C#, as we were just talking about. Xamarin allows you to do cross-platform programming. So not only can you do Android, but you can do iOS. You can also do Windows programming and Mac OS. It does cost, but some people, you might want to look into that. I don't know what happened, but there was another one on here, Delphi. You might not have heard about Delphi, but Delphi is another third-party implementation that allows you to do Android and iOS, cross-platform, Windows and Mac also. In Android programming, you have this concept of a virtual machine, okay? The one that was, this is an old one, I must have not saved the new one. So you work with in Android 4.2 and before, the virtual machine was called Dalvik. Now 4.3 and up, there's one called the Android Runtime. It's just another virtual machine. What's a virtual machine? It's kind of like .NET. It's a virtual machine in which the applications are enclosed and protected. And that's how Android works. Just a little bit about it. You write your code in Java in a .java file with pure Java, with the extensions that Android Google gives you. Then what happens when you compile, you actually taking that Java code and turn it into something called bytecode. And these are highly portable instructions that when the JVM, the Java virtual machine, in this case the Dalvik or the Arch, Android Runtime, he takes that bytecode and he converts it to machine code, specific machine code, and then he executes it. And that's basically how the virtual machine works. In Android programming, you have a number of aspects that we have. One is the presentation layer. This is what the user sees. Okay? You got the processing layer. That's your background processing, however you do your code, your business logic, and all of that. You also have a concept of what's called a broadcast receiver. So every once in a while, the system will send out notifications to all the applications so they can respond. Memory's low, battery's low, whatever the system may send out. You can respond to them or ignore them. You also have this concept of a data storage layer. Basically, that's the embedded SQLite database. SQLite is a very simple, kind of good, I haven't had any trouble with it, database. It's meant for a single user. What's really interesting about SQLite is the SQLite that's on Android is actually the same SQLite that's on iOS. So you can actually take a database from one platform and move it over to another one. Very interesting. You have this concept of intents. Intents is how you invoke different things in operating system. So for example, let's say you want to bring up another activity. We don't get into what activity is. You would use an intent. Let's say you wanted to bring up the camera, take a picture. You would invoke an intent. And basically the way I think about it is you're stating what you want to do, and the operating system takes care of actually doing it. So if you want to bring up a camera, take a picture, you do an intent, picture comes up, the camera comes up. You also have this thing called an Android manifest file. The Android manifest file is basically an XML file that lets the system know about what your application, what special properties it may have, what is imported, what permissions, what icons, different things like that. The Android manifest file is pretty important because without it, the system wouldn't know. It's basically just metadata. And all of this get compiled, if you will, into an APK. Now, an APK is nothing but a fancy zip file. If you really want to do some interesting things, find an APK, download it, rename it to zip, and let's open it. You can see how people actually do their layouts. You can see their bitmaps. You can almost see their code. You can actually decompile the class file back into the Android source code. That's if you like.
I thought that there was some sort of like encryption of it.
You can put it on there, but a lot of people don't. You can obfuscate it, kind of like in .NET, so people can't take that class file and go back to the representation of it. So let's talk about Android programming. An activity, I kind of mentioned that before. What is an activity? An activity is basically an XML layout in your code that's presented to the user. So every time you look at the screen in Android, that's an activity. Okay? Now, an activity can be a hybrid. Sometimes it may not have code, but it's still an activity. But for the most part, in all of our applications, an activity is something that the user sees, is interacting, and code behind it, Java code. You can have multiple activities in an application. And that kind of makes sense, right? You have a login screen, and then you have a main screen, and you have another detail. 3 activities. Each of those activities has to be declared in your manifest file. So anytime your application goes from one activity to another activity, the system has to know about it, and you declare it in your manifest file. Each activity has a life cycle. So it's created, it gets a couple messages, then it's stopped and destroyed. We're going to look at a detailed picture of actually the life cycle. And these life cycles also have events. So when somebody clicks on a button, your application, your Java code, is going to get a notification. User pressed this button. Now it's up to you to do something with that response. Here's the life cycle of the activity. I hope everybody can see that. So, So when your application is invoked, let's say your application is installed and the user clicks on it, okay? Your main application, your main activity, I should say, that gets invoked, is going to get an onCreate. That is where you actually set up anything that you need to present to the user. Typically, you load an XML file so that people can see your layout. You may do some connectivity to the database or something like that. It's got to be quick, because that onCreate, if you take too long, it's going to look like your application is slow and started. So one technique that a lot of people do is, if you can do it in the background, do it in the background. So maybe the connecting to the database takes a long time, so you just spawn off another thread, and it's in the background. That's pretty typical of an application. After you get an onCreate, you're going to get an onStart. And I'll come back to that in a little bit. And then you're going to get an on resume. And on resume, when you get an on resume, you can assume that the user is interacting with your program. It's up and going. And the user is interacting with your screen. Well, let's say you get a phone call, right? What happens? Well, your application goes to the background and you get an on pause. You get this one. When you get an on pause, you can assume that your application is no longer in the foreground, right? It's still active, it's in the memory, but the user is actually doing something else. One of the things that we use the on pause for is like for GPS, okay? So when you are actually interacting with your GPS program, you want to get GPS locations. But when it goes to the background, well, you have to decide, but you can stop taking GPS locations. Okay? That's one of the reasons you use it on pause. If you're in the background, obviously you can come back to the foreground. And as you can see, what happens is it goes back up and you get another on resume. So anytime you get a resume, an on resume, you know that your application is coming to the foreground. It may have been paused before, but now you restart. If we go down here, you get an on stop. An on stop means that the system has decided that it's going to, it needs the memory that your application has. So what it does is, it basically kills the memory in your application to make room for it. Okay? You can still get restarted, as you can see from this line. Basically restart, you go back and you get an on start, and then you get an on resume. Okay? And then obviously your program can be destroyed. Most of the time, the only thing you're going to respond to is the on create, probably on resume, and an on pause. Most of the time. You're not going to do too much after that. So here's a very simple Android program. In fact, before I even go into that, why don't I just show the Android application. So this is how Android Studio starts when you start up in it. I think I have a slide coming up on the prerequisites. But basically, to do Android programming, what you need is the JDK. You need version 7 or up for the JDK, okay? Particularly for Android version 5. Then you download Android Studio. It's pretty much very easy now. If you download the JDK and install the SDK, the Android Studio, it's pretty much easy. They really did a good job in doing it. You don't have to do too much configuration. After you load it, one of the things that you want to do is invoke this SDK Manager. So as you know, Android has a number of different SDKs, different versions, right? They're on 5 point something now, but there's actually SDKs for version 4, version 3. You get Google Glass, you get wearables. Each one of these have a different SDK. I actually don't like this one. I actually prefer this one, the standalone SDK. So this is the SDK Manager, and what it's telling me is that there's a new update for the SDK tools and the platform. So if I want to, I can install it. Android 6, I haven't downloaded any of these, as you can see. The ones that are pretty important to keep abreast of would be these, right? Particularly the USB driver, the Google Play services, the support libraries. Those are always good to keep up to date. Okay, and these are updates that they provide so that your app can be more compatible, more features. When Android and Google release a new features, they do it in the support library, like an add-in library. And this way, they keep it backwards compatible with previous versions. I actually go in there about once every week or two to update. Some people go in there every day. I'm not one to need the latest, but however you want. Google's pretty good at telling you when there's a new update. The other thing that we want to look at is what's called an Android Virtual Manager. Well, I'm sorry, Android Virtual Devices. So when we're writing our programs, what we want to do is test our programs out. It's good if you have as many devices as you can, but that becomes pretty hard and expensive. So they give you these virtual devices that are software enumerations of the physical device. And that's how you test your application. They always say use a real device if you can. And that's kind of hard, but you should. So as you can see, I have several devices here. I have one for a Nexus 5. I have two for Nexus 5. The difference is one is at API level 21 and one's at API level 22. I have a Nexus 6 at API 21 and a Nexus 9. So ideally, when you're developing your program, and you get to a point, you want to run these programs on different virtual devices, just to test how it looks and how it feels. You want to test it on different orientations. So you got portrait and landscape, because it does look different, and it provides a different experience for your users. This is Android Studio. It's based on IntelliJ. It's an IDE. I don't know if it's better than Eclipse or not. I'm used to Eclipse. It's okay. It has some really nice functionality to it. It's what Android now, Google now, wants everyone to use. So let's go back and look at an example of a Hello World program. Very simple program. So what we see here is the package at the beginning. This package is probably a very bad name. A package name should be unique, and it should identify not only your company, but your product. So a better name would be package com.that Microsoft, name of a company, then maybe Office, and then maybe the application project name can be Word. The reason you want to be careful with your package name is when you upload it to Google Play, it has to be unique. So if somebody else have a com.hello_world on Google Play, I can't upload it. So you want to make sure that your package name is unique in order to upload it. Otherwise, you have to go back and change your package name and everything else. How many people are familiar with Java? Does everybody know what kind of Java? Okay, good. So what this statement does, as you know, activity is, again, in the Android framework. And my main activity, and it can be named anything, extends the activity. Okay? And I'm overriding the onCreate method. And as we saw in the life cycle, this is the first message that you get, that you respond to. In this onCreate, I call the my parent, so he can do any initialization. Okay? And I pass him what's called a bundle. In this case, it's named Save Instance State. I'll come back to that in just a second. The next thing that this does is it set the content view. So basically, this layout, the layout name is called activity main. It's an XML file. It loads it up, gets it ready, puts it on the screen per se, and then the user can start interacting. It's kind of basic. There's a lot of stuff missing. But basically, set content view loads up your XML. The bundle. Remember I mentioned before that Android can actually kill all of your memory, all your application memory. Well, a bundle is where you can store pieces of information so that if you need to, you can recall it. Now, you can't store a whole lot, but you can store enough so that if you detect that you are coming back from a on stop, you can look into your bundle, get some variables, and hopefully recreate your program. Okay. It's not always possible, but you gotta watch out for it. The other thing is, if your application actually is killed, and you detect you're coming back from an on stop, you can just kill the program yourself and just say you just gotta start over again. That's the cheapest way, but you can do that. Here is a layout file, an XML layout file. This layout file is a relative layout. I'm going to talk a little bit more about the different types of layouts, but this is a relative layout. I'm giving it two attributes, width and height, and I'm saying that this layout is going to be as wide as the parent, in this case the screen, and as high as the parent. So it doesn't matter if it's a phone or a tablet, Android is going to figure out how big that device is, and my relative layout is going to fill the entire screen. The next couple lines is my text view, just a simple label. And what I'm saying is my width and my height is just enough to show whatever's in there, wrapped content. Whatever is, if my string is hello world, which it is, right? The width of it is going to be how many pixels it needs to be wide and how many pixels it needs to be high. The layout attribute says, I want you to center this text view vertically and horizontally. So in this case, it doesn't matter how big the layout is, the device is. It doesn't matter what orientation it is. Android is going to figure out to put this right in the middle. And that's what this layout does. Here's an example of what we do a little bit more of, right? It's basically the same one, but now what I do is this line is actually defining a text view, a label. I'm declaring a variable called TV, text view. I'm casting it to a text view, and we'll talk about why we need to cast it in just a minute. And I'm calling a function called find view by ID. So what it's going to do is, if you look here, the ID of this text view is actually called text view. Not very descriptive, but you know, that might be like a name label, an address label, and then here I would say find r.id.address label. So what I'm doing is, the XML defines the layout, the set content view loads it up, and then the text view line, the assignment here, actually connects it. So now I can do something with that text view. I test to make sure that I actually got the text view if it's not null. And then what I do is I set the text to more hello, just make it backwards. Yes?
And in SAML file, can you explain the symbols? Because it's not exactly ID. It has some other symbols. If you open SAML, if you go back, what does it mean? So it's not the exact ID you mentioned.
Okay,
So you have plus and you have add sign, plus ID. What does it mean, the symbols here?
Okay, so this is a notation. So this Android is like a prefix.
No, that's understandable, yeah, but later, yes.
Right.
You
And then what
can
we
see
have
what
is
does it
this
mean.
at sign is declaring like a special symbol. Okay, there's a couple of at signs you can use. One's a string. This is an ID. So basically, what he's going to do is the preprocessor is going to look at the XML file. He's going to generate a define, a constant. It's going to be random more or less, and this actually is a number.
And plus means what? Why plus there?
I'm sorry?
What is the meaning of plus? Sign plus.
So that's a notation that Google has. I don't know what the plus.
So for ID, you always have to supply it, yes?
If you're gonna reference it in code, okay? Let's say you have a label, you're not gonna change it, you just wanna put it up, you don't need an ID. But if you're gonna reference it in code to do something, you need an ID. Because that's how we, in this text view, find the ID in the XML.
Assumption you have to supply plus sign, the whole notation, you follow the syntax.
Yes.
Okay.
And I'll show you how the designer, you can type it out. I go back and forth. Sometimes I type out my XML, and sometimes I use the designer. You can use both, it doesn't matter. But that's what that's doing. And I'm gonna show you how to do this in a designer document. Actually, no. So one more thing that I want to mention is this activity is named main activity. The layout name, as you can see, is called activity main. You can name it whatever you want. A lot of times my application may have a activity called start. This is the first one that starts. Right? The layout name can be whatever you want. It doesn't have to be the same name. It makes it easier to look at things if the activity name and the layout name is similar. And also your menu, your menu name will also be activity main, whatever you want. It makes it easier when it's the same name. It doesn't have to be.
You have the sample code on GitHub.
I'm sorry.
You have the sample code on GitHub so that you can download it simultaneously.
Say that one more time.
We have this code on GitHub or something.
I will put it on GitHub. I will put it on GitHub. And do remind me, because I do forget a lot. I'll put it on. Yes, sir.
Increasing or decreasing the font size? Yeah.
I can. Let me see. Let me see what it says.
Newsflash, guys. The Packers on 10, Bears 13.
We're gonna start putting away the food in just a second, so if anybody would like seconds, you should come get them now.
13-10 Bears.
Oh, okay. Let's do the settings. 1 second. And there should be I think this is it.
Sorry, Edwin.
I'm sorry.
Just trying to keep people posted on the score.
That's okay. I'm increasing the wrong one, I see.
Just the control and then the swap work.
Yeah, that's what I was
Is that better?
Just control and then inside there, does when your scroll bar, does that actually increase it? It's the same in Visual Studio, I don't know what that meant.
No.
That's what most notepads do, this one doesn't.
Yeah, I actually had looked it up and just give me editor. That's where it is.
Oh, there it is. Oops.
Give me 1 second to figure out where it's at. I'm sorry, I don't know where it is to increase the size. It looks even worse, huh? I'll try and do it in just a second. So let's just create a layout and see how that's done. Because that's one of the things that we're going to spend a lot of time doing as you do your Android programming. So here I'm creating a layout resource file. You can name it almost anything you want. Let's call it test. I can specify a linear layout or a relative layout, and I'm going to talk about those in just a minute, the difference between the two. Let's just use a linear layout right now. And this is a linear layout. Here it's telling me that's my device. There's a linear layout. I can put a text just by dragging, very similar to like Visual Studios. And basically what I did was just drop in a control. The IDs that he was asking about is I can go here and I can type in ID. So I can type in main label. Okay? So that's my label name that I will use in my find view by ID. And if we go look at the code, XML, you will see that the ID, which is right here, is called main label. If I want to, I can go in here and I can actually change it inside. So I can just make this label. If I go back to the designer, the updates. So you can do either one. You can do an XML or you can do it in the designer. Okay? And again, this label, as you see, I just typed in label. I just typed in a name. I didn't type in a plus. I didn't type in anything else. But you can see that he actually put that syntax in. Plus ampersand ID / label. So that's a convention that he uses. And that's just the format of it. This text right here is showing you a warning sign. And basically what it's saying is that text is hard-coded in. It's not in a resource file. Typically, you want to put all your text in a resource file. Because then what you're able to do is you're able to do localization or internationalization. You can take all your strings and convert it to another language. Android will figure out which language the device is, and if you have those strings in that language, all the text will be automatically displayed. Now you got to be careful that it all fits and everything else, but that's something else. But that's how you do internet localization on Android. So let's talk about these views for just a second. Because everything in Android is a view that you see. Everything that you see in Android is a view. As you can see, this is the hierarchy of many of the objects in Android. Everything is derived from a view. The text edit that we had looked at is inherited from a view. A button is a type of text view, which still is inherited from a view. So every control that you see on the screen would be inherited from a view. That's why find view by ID, it returns a view. But what kind of view? We have to cast it. And that's how that works. And that works with almost any type of control that you have in Android. You always have to cast it. There's a special kind of view called a view group. A view group is a collection of views. And it can go on and on and on. You can have many views within a view within a view. So you can have a linear layout, and then you can have more linear layouts, and even more linear layouts, and then you can put the specific text view inside any one of those. Now you don't want to get too crazy in doing a lot of these layouts, but sometimes you have to. Sometimes you may have, let's say you have a name label and then an edit box, okay? You can put that into a linear view and it'll show. But let's say this time that the user is executing it, you don't want to see that name and that edit view. You can hide that view, and both those controls would go away. The user would see it. So that's one reason why you would. Maybe you want those controls to be a different color. Maybe you want them to be transparent, like in a camera app, right? So you have controls at the bottom. So you put all your controls in a linear view, and you can make that whole control transparent. So it kind of, you can see through it. Otherwise, what you would have to do, and again, it's not that difficult, you would have to set the transparency of each one of those controls. So it's however you want to do it. Here's an example of a linear view. The first one is a linear view, but it's horizontal. Whatever those views are, either other view groups or controls, in this one, because it's a horizontal layout, all those controls will be laid out horizontally. The bottom one is a vertical linear layout, which means all the controls are going to be laid out vertical on top of each other. The other side, a relative layout. A relative layout is the preferred way of doing layouts. Why? Because you set up your layouts relative to each other. That makes a big difference when you have different sizes. Okay? So for example, in this relative layout, this control is at the top and to the right of the screen. So it doesn't matter how big it is or how wide it is, this control will always be on the top left. This next control is always going to be at the bottom of this control, is relative to another control. This control is always going to be in the center of the screen. This relative layout says that this control is always going to be at the top, no matter if it's portrait or landscape. This control is always going to be lined up to the left of this guy. And this control is always going to start at the center and go over. Again, most of your layouts, your main layout should be relative. If it's not relative, then what happens when you have different screen sizes, like this one versus this one, or even landscape? It's not going to look the same. But if you do it relative, then it really doesn't matter what layout it is or what size. Android is going to try and make the relativity of it the same. I'll show you some examples of that one. So here it is. So now I can make this layout. Let's put a button in. So this button is always going to be, as you can see, left and to the bottom. This layout is always going to be centered and to the bottom. And this layout, this button is always going to be to the right and aligned to the bottom. So now if I change this layout to landscape, same thing. Well, that's a checkbox, okay. But you get the idea. is to the bottom, okay? The other side of the coin is this. You can have different layouts for the same view. So let's say you have a layout. Go ahead.
You have spaces. Can you keep it together?
You could.
Yeah.
It's different properties. So what I would say is, what you would do is, you can say it's going to be right next to it. Okay? So now if I change it, it's going to be right next to it. I can also put in there what's called padding. So what I can say is, it's not padding. So I can say, make sure that this button has 30 dp padding. I'll talk about dp in a minute. See, it's a little bit confused because I specified it being next. So probably I want to get rid of this. Get rid of this. The module. So you can specify that one control will be next to it, but always leave a little bit of space between the controls. Or you can have it right next to you. The padding actually specifies within the control how much padding do I have. There's a slight difference between a module and a padding. Okay? So this is how you do a layout. Again, you can put other layouts inside of this. I can put in another, let's put in a vertical or horizontal layout. It's going to be at the top. And I'm going to match the parent. What I'm going to say is the height is going to be, well, let me change that later. So I'm going to put in a large text view here. And I'm going to say that the height so if you see, the height of this layout is as big as the content. There's only one control in there. If I put another control in there, it's going horizontal, so it's going this way. If I change the orientation of this guy, if I change the orientation, you will see that the height of this layout has changed because now there's two controls and it's vertical. And this control now is however big. I can change the width of this to be wrap content. And so now this layout is going to be as big as and as wide as however many controls I have. If I wanted to hide this control, there's two attributes for hiding and showing. The default is visible. If I say that it is invisible, then you just don't see it. It's still taking up space, you just don't see it.
Good question.
Mhm.
This is hiding the visible. Will not collapse the frame like box when you put it in. Because if you hide it, it will take the place.
Yes.
But if you collapse, it's different property probably.
Right,
That
so,
does it have it collapsing? Will it collapse when you hide it or not?
right, so if it's invisible, it'll just hide it, it's still taking up
But
space.
yeah, it's still.
Okay, if I change it to gone, then it doesn't take up any space. And anything below it kind of collapses up, it depends on the property of the layout. So if you have fields that you don't want to show because of certain privileges, you can hide it, or you can just make it gone, visible. And again, you can do that to the layout, and all the controls will be hidden. Or you can do it to each individual ones if you want. Yes?
Can you have separate screens and say, okay, I want to go from this screen to this screen and not have to collapse this?
You could. You could. You can also have different layouts, right? So you can have one layout for one type of privilege and another layout for another type of privilege. Now, you might get into, you might be making more work for yourself because now you got two different layouts. Suppose you have to add some controls. You got to add it to two layouts. Okay? The other thing to keep in mind is everything that we saw here, we done in the XML. You can also do these things programmatically. So let's say you have a screen that you want to dynamically create at one time based on whatever properties that you want. Anything that you see in this XML, you can actually do in code. In fact, when we call this function in onCreate, give me a second, find it here, which is called